Good afternoon and welcome to my slideshow on student tools and applications. I'm going to step you through the 10 most commonly used tools and applications that are geared towards the student in my classroom. That includes Drafting 1, Architectural 2 and 3, as well as Mechanical Design Engineering 2 and 3. I'll lead off with Varsity Tutors. Varsity Tutors I use across the board. It's an excellent online student account that allows me to really fuse the material that I capture in the classroom lessons with that of an outlet for them to go to online by way of their student credentials in gaining access to support material that complements their learning in class. And I find that they really gravitate towards this tool because they love the way that they can take ownership of their own review material. Next, I'll lead off with what really amounts to the essentials in Drafting 1 in terms of manual drafting. I incorporate the Alvin Drafting Toolkit that basically captures within that kit all of the manual drafting tools needed in order to cover the NC essentials in Drafting 1. I'll spend maybe 3 to 4 weeks max with this material before we move on to the software portion of the class, but the students are taught in each and every case, whether it's the divider, the compass, the scale, to make use of these tools, not only in an applied sense, but also in a manner in which they understand their intent for sake of the final exam. Next, I have an HP DesignJet plotter in class, and as you can see from the link, it's a dated piece of equipment, but still moves on eBay quite a bit, as well as Amazon. I like it because it's got the capability to go grayscale as well as color, and it really comes in handy when you're looking to print out presentations that require drawing sizes of poster or greater. In the real engineering world, especially in architecture, there's often the need to still go roll size plot, and this printer will allow you to go roll size. By that I mean as many feet long as or wide as necessary by 3 feet in height. And again, this is still an invaluable tool for not only learning in the classroom. That's why I'll always hold on to this piece of equipment, but also for sake of its use still today in industry. It's a valuable tool for the student to learn. Next, we start to branch off into our first piece of drawing software that everybody touches, whether they're going down the architectural track or the mechanical engineering track, and that is AutoCAD 2016. That's the current version that we have in North Carolina with respect to the classroom. It's the primary drawing tool that everybody uses regardless of what track you might end up going down, and it's a valuable software in that the student not only makes use of the 2D tools that lead them into the 3D software tools that come later, but they also use the terminology and come to understand the terminology that's used across the board in the CAD industry, whether it's on AutoCAD or any other software tool that they should come across in the future. So we'll spend the bulk of Drafting 1 in this software once we get through the manual drafting tools. Next, at the end of Drafting 1 and when you start to venture into Drafting 2, 3 with respect to mechanical engineering design, we get into the third dimensional world of solid modeling in Autodesk Inventor. Autodesk Inventor makes use of the student's understanding of AutoCAD insofar as being able to generate a sketch in two-dimensional mode and being able to plot that on flat roll size paper. Now we're starting to get into the third dimension where you're building a model that has weight, mass, and scale to it in such a way where you're going to manufacture that part. And we'll get into a couple of those tools a little bit later. The student will have access again with this tool on the same personal workstation that they've been working on all along in AutoCAD 2016. And again, this material comes at the end of Drafting 1, but will be their go-to software for drafting 2, engineering, and 3. Next, if we start to venture down the architectural track, we'll go in the direction of Revit on the student's end as opposed to Inventor. Revit is the 3D equivalent, but it's geared towards architectural design, of course, as opposed to mechanical design. So students making use of this tool will design elevations of residential floor plans in the interest of designing a home. The tool, again, much like Inventor, will take you down the engineering drafting 2, 3 track. This will take you down architectural 2 and 3, but it also provides a nice foundation for those that are looking to go into civil construction or residential design in some capacity in the future. And Fusion 360 is essential in starting to cross over from design into manufacture. This is the tool that actually takes what the students drawn and allows them to generate cutting path for sake of creating a physical model of their design. In other words, once they've mastered Inventor and they've come away with a design that they'd like to manufacture or create, this will allow them to create the machining steps to accomplish that task. Next, we have what we make a great deal of use with in the honors classes in particular, and that is the smart camera with ImageMate software. This camera software combo is what I use predominantly on the students' part in allowing them to prepare for presentations. All of the students, whether it's drafting 1, 2, 3 in architectural or mechanical design, they all have an end of semester project that they're responsible for. And part of that project, in addition to the design and build, is being able to present that material in front of the classroom. And what I like about this package is it allows the student to practice on their own in not only their delivery, but in the timing of their presentation. Next, what we have is our first offering in the way of a 3D object tool, and that is the Ultimaker 3D printer. The very first step we take in generating a physical part is creating that part by way of the 3D printer. The 3D printer is an essential tool that's used in industry as well as the classroom in determining whether or not your design, meets the design intent, number one, whatever that criteria may be, but also is able to be made and being able to be ergonomically correct as to your specifications. So it gives you an opportunity to 3D print in plastic, for sake of being able to take some measurements and take some inventory on how well that part will prove out in its final material. And then speaking of the final material intent, this Tormach PCNC milling machine will allow you to create a part in its entirety in the final deliverable state, whether it's a steel, wood, or polymer alloy. You will set up and operate the machine after having had AutoCAD, Inventor, and even a mastery of Fusion 360. And that is for sake of this being the final step of the class for those that are going down the engineering track in generating the machine code that this machine will run off of for sake of being able to produce a part. And that